also need to bear with me for a few more minutes because I want to introduce today's agenda and a short overview of who is behind today's session. So, as you know, we are talking about very smart topics as bioengineering and materials science. And we have two universities, German universities, and of course, two speakers who will be presenting them. I will introduce both of them also separately. Now, who is behind today's session? This is German University, which has a database of English taught study programs in Germany. And this means that if you want to study in Germany fully or partially in English, you are welcome to use this study finder in order to find a relevant program in a short period of time, since the study finder has lots of filters that you could adjust then your desires. And the filters are not by only location or university or a program name, but even deeper, for example, deadlines still open, or regarding tuition fees, admission restriction, your English language scores, etc., etc. So feel free to combine those filters, and then you probably find the most suitable program. But however, today, probably one of them will be presented right now. What we also have is articles. Those articles are for sure worth of your attention, since they are written by internationals who are trying, or we are trying to then share the insights of studying in Germany from different perspectives to you. And I know that scholarships is a big topic, and we have a whole series of scholarship articles, especially from 𝘗𝘪𝘵 and also other scholarship providers. So I'm sure there will be questions about that today as well. And I will be linking then these articles because they are also country specific. For example, for people from US, Nepal, India, Georgia, and others. And finally, to stay connected and also have more communication or direct communication with you, we have two groups of webinars. General webinars, when we talk about broader topics like Uni Assist, visa, studying in Germany, scholarships, and so on. And then we have subject-related webinars. The one that you are attending right now is one of them. The webinars and articles and everything else is free of charge. You can register for them, and then your preferred program will be presented. Or if you want to attend a general webinar, then one of my colleagues will be presenting a general topic to you. And of course, nothing would be possible without this great team from different countries. Everybody has experience, like many of them are also German, but the internationals have experience of living and studying in Germany. And then this brings two perspectives of the same like outlook of how it feels studying and living in Germany from internationals and from Germans. And then you can gladly use this information for your benefit. And there were also some flex, which means that articles and webinars are in multiple languages. Now, since you are attending today's session, then hopefully you have searched for programs in bioengineering, material science on the page, maybe in our study finder. If you have not, then I did it for you, and you can see 105-degree programs in these subjects. The breakdown is also visible, and English only option means that the programs do not require knowledge of German throughout the course. If you don't know how it feels studying these subjects in Germany, then we even have subject pages which provide a general overview of different information, like about application, admission, list of universities, rankings, etc., etc. So you can also have a look, and I can also share the link in chat as well. One tip would be to always consider multiple factors when selecting a program and not be guided by single things like city names or rankings, because the programs are much more than that. Professors and everybody who is working on the program is trying to create a unique timetables or syllabi for you. So it's always important to really understand what the program is about and then apply accordingly. Briefly about the university landscape of Germany. If you search briefly, you will see that there are two big groups, so to say, the universities and University of Applied Sciences. Universities are more research and theory oriented. Universities of Applied Science are more application practice oriented. However, there could be some exceptions on both sides. And finally, I want to mention that when searching for programs, it's better to filter by subject, not a program name, because not all programs are Master in Science or in Bioengineering or Master and Bachelor in Engineering in Bioengineering. So it could be a different name. And therefore, not to miss out the programs, it's advisable to select or search by subject. And now this brings me to our first guest from Rhein-Waal University of Applied Science, presenting a Bachelor's in Science program, Biomaterials Science, Professor Dr. 𝘗𝘢𝘪𝘥𝘪𝘯𝘨, who will be taking over now for another 15-20 minutes. He can present the study program. And then I go to the background, allocating and answering your questions.
There, and I will try to get back to proper speaking. It's a little bit difficult. The thing disappeared. So this is us, the obligatory picture of our campus. Today I'm trying to advertise our biomaterial science degree, but to mention that we also have a bioengineering degree in a separate faculty nearby, and an attached master's to this biomaterial science degree, which is similar, doing more of the same at master's level. So this is it. We're a new university built in 2011 in a quiet part of Germany, shown on the previous slide. That makes the cost of living comparatively low compared to big cities, for example. Rent mostly. What else do we want? Oh yes, most of our courses are in English, so that means people that you randomly meet on the campus will speak to you in English and not in German. And the library, which is that building in the middle there, is mostly full of English language material. Yep, now I can't flip. Oh yes, so that's the zoom in again. On the border to Holland, it's quite easy to get here. So you can get here from Düsseldorf and from airports in Holland and by ferry if you happen to live in England. The students at our university get a free state ticket. Well, free, they have to pay for it, but it's very cheap. And they can travel for free on buses and trains, and they can also get into the closest town, which isn't in Germany, it's in Holland. It's called Nijmegen. And that's where most of our students go to hang out. What else have we got? Oh yeah, so this is also a picture from the other parts of our faculty of sort of engineering type stuff, but we have chemistry labs which look more like normal chemistry labs. So I didn't bother to put any of those in because they look exactly the same in every university, everywhere, benches and fume cupboards and things. They're just identical. They look the same in all universities, but ours being new don't smell quite as bad, which is a nice thing. Going back to the Fachhochschule university difference, in our particular case, we are, this course at least, is relatively academic, so we are more like a university than like a traditional polytechnic, which a Fachhochschule would be. So our courses are more similar to university courses, and we see that with what our students do afterwards. So this is how long it takes. It takes 7 semesters, which is 3.5 years. It's in Kleve. You get a Bachelor of Science, which we just choose, as was mentioned before. We could call it a Bachelor of Engineering, but we decided to call all of ours Bachelor of Science. You can join in the winter term only. It's only taught in English. There are no parts of it in any other language. If you do really struggle, you can hand in your last thesis in another language as long as somebody else can understand it. There's a little bit of a question with this internship because the course is changing and we might not have it anymore. The pre-internship, which is a Fachhochschule thing, universities don't tend to have them, but there is another one in the 6th semester, which where you go into a company or you go into a university, do some research or some work, and that can lead onto your thesis. Let me check that I've said all the things I wanted to say. Blah, blah, blah. Yeah, so we have changed our course recently to make it more focused on material science and a bit more biology and chemistry, a bit less maths and physics. So there is a little bit of a mismatch between some of our material. What else do we have? Yeah, so the directions that we have are biochemistry, materials engineering, and management, which you can choose when in a later semester. Yeah, I've already written that there. So we have an upcoming change, which might change it slightly. This is what we define biomaterials as. So what we discover is biomaterials as a word is poorly defined. The old definition in German, German likes to steal English words, the old definition and the English definition are not the same. And so we have defined it as all of these four things: implant materials, which is what it often is considered to be. It would be hips, heart implants, valve implants, and that kind of thing, but also biodegradable materials like biodegradable polymers, bio-derived materials like making polymers out of potatoes, for example, and bio-inspired materials that have the structure of biological materials, structure of bone, structure of wood, but they're artificial. And we like to consider all of these things in our course. It's not always the case. That's just our understanding of it, and that's what we've decided to do. So what it really is a classical material science and engineering course that builds up chemistry and engineering. You can choose one of these three streams later on, which we call focus fields. That's 3 modules together. One of them is more chemistry focused, one of them is more engineering focused, and one of them is management. So you can do something that's like material science and management in our course. But if you don't like management courses, you don't have to choose that one, and then you only get very little management. That's one of the changes that we've made. Now, previous students had to do some management, but not very much, and all of them were unhappy. Not very unhappy, a little bit. Then we have the biology bit, which is the recycling of materials, biodegradation, naturally based materials, biocompatible materials. Oops, that's interesting. And interfaces to biological systems. So that's what happens when you put your material into biology. This is typically what one would expect material science to be, a combination of engineering, physics, and chemistry. And in our case, we are adding biology to it. No, I've written a lot of things that I didn't say. Let me keep those. We're adding biology to it. So if we consider it as a tetrahedron with material science in the middle, it's biology, engineering, chemistry, and physics. Our course allows you to choose a focus because we have these focus fields, but we also have specific projects that you can choose. Actually, 2 projects in the new course. There's the internship, which you can do in a company, but you can also swap that for a year in another university. And so you could do that in biology, or you could do it in chemistry, you could do it in physics or material science, and obviously the thesis, which you choose yourself. That gives our students the potential to choose which way they want to go. The main choice is whether to be a natural scientist or an engineer, first of all, and then inside that there are other choices to be made. And if that doesn't work out, you can always go back and choose one of the others. So we have some examples: sustainability, in vivo behavior, so things like these implants, ecology, engineering, or management. Okay, let me see what I've missed out. What I wanted to say was, we start off as a very normal material science course with chemistry, materials engineering courses, just like any material science course. And we start off with a balance between chemistry and engineering. And then our students choose to go in one way or the other. What is unique in our place is that we have quite a lot of natural science in our course, and we mix it with biology and a little bit of engineering, whereas most material science courses are more engineering-y. People who like engineering still can choose that option and fill it back up to much the same. Blah, blah, blah. Oh yeah, so on a more sort of teaching sales level, our goal is to make our students competent at completing projects, at working on projects on their own. That's what our course is designed to do, obviously in material science. And that's a very transferable ability that you can use to apply to different things. The project can be get a job, it could be anything. And if you consider it like that, the skills of how to do that, ways to do it, are completely transferable. On a side note, we're probably the most international university in Germany. Most of our degrees are only in English, and more than half of our students, well, about 2/3 of them in our faculty, are international, which allows us to offer the low tuition fees, international, and in English. Right, let's go further. I've already got off time, but never mind. What have I missed out? Blah, blah, blah. No, I'll leave that. Let's have a look at what we've got. This is our actual course content, which is obviously very confusing to start with because I'm just throwing it at you. We have only 5 courses per semester, and the general ones at the beginning. Obviously, it starts off fairly general: chemistry, physics, maths, and a business subject, and then it becomes more specialized in materials, corrosion, biocompatible materials as we get further on. Supramolecular chemistry, which is how molecules stick together to make materials, for example. I know it's a lot to take in, but it's on our website and you can look it up. So this is the actual meaning of biomaterials, biocompatible materials, which we would have implanted into people's bodies. And these days, there are a lot of applications of those. And if we think of all of these parts, we can imagine that several of them, it's extremely important that they attach to the tissue. So, for example, the bone. But the joints, it's extremely important that they don't attach to the tissue, and for those, different materials and coatings are used. And it becomes quite complicated because you may well have heard of people who get nickel allergies and things like that. You can have a reaction to the material. We have a nice picture, or not a very nice picture, a picture of some types of plastic. Some of these bags are biodegradable, depending on which country you come from. You may be familiar with that, you may not be. Polymers can be entirely biodegradable. They disappear in compost. It takes a very long time, but they do eventually. And that is good because it's one of the major themes in the news at the moment is microplastics. And if we can make our polymers degrade over time, then the microplastics will also degrade over time, and the smaller they are, the faster they degrade. One of the examples is potato starch, which can be incorporated into a blown polymer, so we can make carrier bags out of it. They don't recycle very well, so it's a complicated subject. The biomimetic materials that I did mention before, but I've got some nice pictures of here in this slide. Wood has fibers that run along, so it's stronger in one direction than the other. It's also better in tension than it is in compression. Bone is tougher than most inorganic materials because it's a mixture of inorganic and organic materials, but the way that they're mixed and the shape of how they're mixed makes it tougher or less tough, stronger or less strong. Tough means it is harder to break, but it's the amount of energy that it takes to break it. So rubber is tough, glass is hard. And shells, for example, if we take eggshells, it is quite difficult to dissolve eggshells because every time you go through, you get from the organic layer, which dissolves and cooks and breaks in some things, and the inorganic layer, which is calcium carbonate that dissolves in acid, but each one has different resistances, and so sometimes they're better than the two things separately. This is nacre, which is mother of pearl, which comes in sheets. It's extremely strong in some directions. So here we go, having this basic part, or the classical part, which some of our students decide to go into. That's what they do afterwards. They go into classical material science. So things like metals, polymers, that's an injection molding up here. Or don't know if you can see that. There's a tensile testing where you try to break things. That's the engineering type. Engineers like engineering, or material scientists that work in engineering like to break stuff. So they break it, they heat it, they whack it with a hammer, see what happens. And if we want to make it more innovative, we would generate lightweight construction. So that would be buildings or vehicles. Vehicles particularly need to be lightweight because you're paying for that mass to be moved. Nanotechnology is more common these days. 3D printing is a very common sort of up and coming thing, from very small up to very large. People 3D print houses, but also very small things. We want to see what happens, and obviously we want to know what happens at the end of the life of the thing, whether we can recycle it, whether we can biodegrade it. What do you do with it? What do you do with this degree? You've got your BSc, what can you do? You can go towards our master, which is called Bionics, but it's actually a biomaterial. It's got a biomaterials arm to it, so you can choose the biomaterials master, and that it behaves like, it's material science, but in the biological way, the biological interface, just like our bachelor degree. You can go onto one of our other masters in our university or somewhere else. I'm going to have to move myself. Oh yeah, and then it says PhD over there. So many of our students choose to do that. Unlike many Fachhochschulen, many polytechnics, a reasonable proportion of our students, more than half of them, choose to do a master and then do a PhD afterwards. That partly depends on where you want to go, and partly depends on what direction you want to go in. Each subject, it's a little bit complicated in life, but we'll try to help you through that. Each subject has its own subject culture. So for example, engineering master is where you tend to go to. In natural sciences, particularly chemistry and biology, bachelor and PhD are really the places that you get jobs at. Our state, so if you go straight from bachelor to work, our state has a lot of companies who do material science. It's a very busy state. It's the industrial state of Germany. So there's a big number of Euros, but they employ a lot of people in material science. And there are local companies here, Spectro in Kleve and Ipsen. They make, Spectro make spectrometers. So there are two other companies that make spectrometers in Kleve, and Ipsen make ovens to tough harden gears. But there are other places very close by, some of them extremely large. Siemens is extremely large and make all kinds of things, which means you can go in all kinds of directions. There are medical companies as well. It is a slightly different, so when you finish your biomaterial science degree, you can go towards chemistry and you can go towards material science. Depending on where you are in Europe at the moment, material science is an easier job market than chemistry is, but it does matter which country you go to. Some of our students come from Asia and they go back to Asia, and they find that chemistry is easier, that there are many more jobs in chemistry in some countries. So you do have to decide exactly where you're going to go and match to that. But that our breadth gives you the possibility to choose if your situation changes. I'm hoping that I've said all of the things, because I do three. Yeah, I got off topic, but never mind. I'm hoping it works. So what did I this is our general information. This is usually somebody else does this, but this is our general information for students of our university. That's just a picture of our large building. Application in biomaterial science and bioengineering is in the winter term, or the courses start in the winter term. Application starts in May, and the deadline is usually in August. For the masters, it's twice a year, which picks up two different types of students, the ones that do 7 semesters and the one that do 6 semesters. To qualify for a bachelor degree in Germany, you have to have some things. It's a little bit complicated in Germany, but this is general. I think my German university people will help you there. Sometimes you have to collect a few courses from a university in your home country to be able to do that. It's a general EU rule these days. That's why it's much more central. You do have to speak English, and sometimes even if you come from India, for example, where we know you really speak English, that you do have to sometimes provide some kind of proof that goes via a company called UniAssist, which I've made a note to mention. UniAssist is a portal which you can apply to several German universities at once. It costs you a small amount of money, so there is a little bit of a hurdle. But once you've paid the money and uploaded all of your things, they help you, and you can apply to several, I think it's 5. You can apply to several universities at once. I'm not sure whether the master does that. I think it might not. For the bachelor, for English, you need a relatively low qualification. I forgot what it is, B2, I think. For the masters, we require a better one, C1, I think. Because I'm not the person that does that, so I don't know exactly. Then we come on to the important thing, which is money. So in Germany, we don't have tuition fees, or most places don't have tuition fees. There are some that do. We don't have them. There is a semester fee, so it's not entirely free, which costs around 300 euros per semester. It's obviously gone up, so it will be a bit more than that. That gives you some. It covers your social services contribution, which you would have to pay anyway. But it also covers a free transport ticket for the whole state, which in our case is a very big state, and so it's quite handy. It does have some other things, so the student representatives and the student sports are covered through that money, but they're not very big compared to other countries. If you're familiar with US and UK, both of those things are relatively small, and that is obviously because you're paying 300 euros and not 9,000. Obviously, places that are taking a lot more money in can afford a lot more things. But for the money, you get the important thing that you get is this free transportation ticket, which if you wanted to buy that on the open market would be about 10 times that price. We do have some student accommodation. It's not very much though. Most students live in flats on their own or in shared flats. We have a website to help you find that. It is, as I mentioned before, relatively cheap. Accommodation and cost of living is relatively low in our place because it's kind of rural. It's not too far away from cities, but it is reasonably rural, so it's easy to find a place. Some of our students live further away. Some of them live closer to us. There's an average living cost. I think ours are lower than that. So that's just a general centralized one, which has rent and heating and everything. So all of those things are included. It's a good idea to be ready for that, but I think we're a little bit cheaper. Oh, that was all of our things. So just to mention, there are 3 degrees that you could be interested in. We have this biomaterial science degree, which is what I'm the course leader of, but there's also a master's, which if you're trying to do a master's, it's something to think about. And we do have a bioengineering bachelor degree. It's in our neighboring faculty, and the reason that my talk is called, if they don't change the name, it's called Biomaterial Science and Bioengineering, is because we often do these together. I probably have overrun, so I'll stop sharing.
Thank you very much for the presentation. I think you answered most of the questions already in the Q&A. So
I'll go and look at that.
Yeah, sure. No, I just wanted to mention that the presentation was overarching and covered all the aspects. So thank you very much for this. And I believe students are also very thankful. Now this brings me to our second guest, because I already noticed some people also want to do a master, which is really great. And here we go. Oh, you can hear more about the Masters of Science level degree, Advanced Materials Analysis, that will be presented by Dr. 𝘗𝘓𝘕𝘓 from 𝘗𝘀 Freiberg. And then I stop my screen share. And again, I will be sharing the information in chat, so follow me there.
Okay. Can I start? Yes.
Of course.
Okay. So and now I hope you can see it. Yes.
We can, if you want. Yeah, now, perfect.
Okay, good. Also, hello, my name is 𝘚𝘓𝘕. I'm an academic advisor at the Faculty of Material Science and Technology at the University Freiberg in Germany, and I want to introduce a master degree program, Advanced Materials Analysis. With me is online my colleague, Mr. Thorsten Meyer. He is a member of staff of the International Center. And the International Center, for instance, offers events regarding general living, general facts or information about the study, and also, for instance, living in Freiberg and other things. Okay. I will start first where is situated Freiberg. Freiberg is a little town in Saxony. Freiberg has about 42,000 inhabitants and is in the near of the capital of Saxony, approximately 30 kilometers, and approximately 200 kilometers in south of Berlin as the capital of Germany. And we have also airports. The airports is, for instance, in Dresden or in Leipzig and Berlin, and also Prague. Now, Prague is, Prague is, I would say, 50, 60, 70 kilometers in the south of Freiberg. The university in Freiberg is a little university, it's a technical university. We have about 4,000 students, and actually I cannot read my text because there is a, okay, I hope I will see it. Okay, and we have, you can see the profiles, we have faculty or mathematics, we have informatics or computer science, we have economics, we have geoscience and geoengineering, we have mechanical engineering, physics, chemistry, and also we have also material science and technology. Now it's, I think, a wide field, and this is and the master degree program Advanced Materials Analysis is an English master program. The courses are given in English. The duration is for semesters. That means at the end you have 220 credit points, and you will finish it with a master degree of science. The degree program has no numerous clauses. That means you have only to the requirements. I will say later something, and we have no fees, only the administration fees. Actually, we have also fees as €94 per semester. Actually, the start of the course is in the winter term. That means early in the October. And the master degree program, we have some institutes, especially in the field of material science and physics. And you will see later it is also, this is a, see it also in the contents that such institutes has influence or contribute to the contents of the degree program. That means, for instance, we have the Institute of Material Science. We have 3 institutes in the area of physics, experimental physics, advanced physics, and theoretical physics. And we have also electronic and sensor materials as institutes. So, and the main topics is, you can read it also, scientific background in experimental methods for analysis of atomic structure, microstructure of functional materials using microscopic diffractioning and spectroscopy. That means you will have you will much learn about the analytic techniques. And why? The aim is to understand the relationships between the production technologies, the structure, matter, and the materials properties. And we have also a wide range of materials, for instance, materials for electronics and optoelectronics, batteries, thin film hard coatings, and shape memory alloys, titanium alloys, and modern steel and more. This is only some examples of this, of the content. So the requirement for the admission. For a master degree, you need a bachelor degree, a minimum 6 semesters. In the field of material science or physics or chemistry, but it's very important that you have knowledge in the field of solid state physics or solid state chemistry. We have many applications in the field of mechanical engineering, so most of them, we have to say, you will not get an admission for the study course because it's very scientific. Also you need really knowledge in the field of material science, materials technology, and also or physics or chemistry. Important is you need an English language because all courses are given in English. For instance, a TOEFL with minimum 90 points or IELTS with minimum 6.5 or your equivalent tests. The application for the winter semester or winter term is possible between the 1st January and the 15th April. And this is a master course. Therefore, we have an online application portal. You see the address. In this case, it's a master course. Don't use the unit assist, Uni Assist. Also Uni Assist doesn't work for application for this master course. Now, I think it's only possible for bachelor degrees, for bachelor courses. Okay. So then, what is the contents? You see the dark blue, also the blue, this is the mandatory courses. Now you have the introduction atomic and solid state physics, functional nanomaterials. You have that was a wish of the students. We have a new regulation, and sometimes the wishes of the students have an influence on this plan. Fundamentals of crystallography, quantum theory, and you see structure, microstructure analysis course, also materials research with free electron X-ray lasers. And you have also spectroscopy in the 3rd semester, laser physics analysis of the real structure of matter. And during the 2nd or 3rd semester, you can, as a student, can decide if he want to start in the 2nd semester or the 3rd semester. The student has a research project. That means the students get a task and have to solve the task, for instance, laboratory at the university. And then you can also you have the possibility to elect courses now from the offering of the university. And in the 4th semester, the final is the master thesis with 30 credits. That means you have for the master thesis a time of 6 months, right? And for the you have to solve a task, you have to write an paper, and then you have at the end an presentation. So, and after the 4th semester, also you have a degree in Masters of Science. Okay, we have also an own web page. You see it with on this page now in English. This is the most important information about the study course. Also, the examination and study regulation in English in this case. I think, the job opportunities. It's clear we have research and development. Now we have, for instance, in Dresden, research enterprises, or yes, for other institutions, 𝘱𝘢𝘕 Institute and other things. And you can also work after the study in the quality control, also material analysis. Now, semiconductor industry, ceramic industry, steel industry, and you have several possibilities to work, or you can at the university make a PhD position, work at the university for a PhD degree. As the contact persons is the Dean of Studies, is Professor Rafaya. Greetings from him. He is on holiday actually, and therefore I tell you something about the study course. Professor Rafaya or academic advisor, that's me. You have the phone and you have also the information about the email address. And I think the last page is, I'm at the end. And now,
thank you very much. Thank you for the information and also for the details. I will put the email in a moment while we start answering the questions. Yeah, the audience, thanks for being active and for your questions. I will now start with the ones that are just came in, or then Dr. Renke, since you have just finalized, I could start with you. The one question was, at least like the question came twice, what does NC mean? I saw that it was answered in written, but if we could voice once again, what does it mean that there is no restriction on admission?
what is moment?
So,
so we have no numerous clauses.
Yeah.
Okay. That means it's you will get an admission if you have. Also we check which subjects did the student pass during the bachelor degree, also the bachelor study course. Now that's all. We don't check the final grade, for instance. Now it's only relevant what was the contents of the bachelor.
So yeah,
and very important is also the English, the English knowledge. This is also relevant.
And also NC was for Rheinwald, right? There was no restriction.
No, we don't have one at all, not in our faculty.
Great.
But for international students, it's not quite the same, because we still require that they do enough credit points to be able to join the European system. So I advise them usually to check with their international office or with the other international office, so they know exactly what it is that their university translates to. It's a little bit complicated converting systems.
But for bachelors, do you pay attention to any, because I saw that somebody was saying, I have interest in biology, but I don't know if should I take the course. So do you pay attention to high school grades?
No. Well, yeah, yes and no. So it's the German system is if you have an Abitur, you can join us, and it doesn't matter whether you did chemistry, physics, or biology. The German education system is a little bit broken. So it assumes that it's a general entrance qualification if you finish school. And in our state, in North Rhine-Westphalia, it is possible to drop physics and biology completely and only do chemistry. So we are familiar with that kind of students. That's completely allowed. We don't stop. We don't filter for that. We assume that if your school has done its job properly, you are capable of doing our degree. It doesn't mean you should bring a little bit of interest in chemistry and materials. Otherwise, it's going to be very difficult.
All right, thank you. Dr. Renke, there was a question. Is it possible to specialize in metallurgy, for example, during the electives, or I think the last part was some...
And metallurgy is very often, in Freiberg, very often in material technology field. Also this is, I think the correct answer is no. It's possible to search, okay, elective module perhaps in the field of, also we have other study course, metallic materials technology. So it's possible to take, for instance, steel technology, foundry technology, non-ferrous metallurgy, or the fourth, I have a metal forming. Now, this is a special English study course for metallurgy. Now, I think it's in this case better to use this, also to elect the MMT, also metallic materials technology course. The advanced materials analysis is more scientific, also more. I think theoretical is not so correct, but it's more physics, it's more material science.
Mm-hmm. All right, thank you. Then I will stay with you and then go to Reinval and Professor Dr. 𝘱𝘢𝘪𝘵𝘯𝘪 about the option of having publications. I saw one question, which I cannot see right now, was, is it possible to attend ongoing researches at the faculty and then maybe write papers also with professor or tutors? I don't recall exactly the wording. Yeah, good afternoon. Does the faculty offer possibilities to take part in ongoing researches and write papers with tutors?
Who, für beide? Yes,
Yeah,
this is possible. Also, I have said we have, for instance, a research project is a study work and also the master thesis. And if this is a good results and the professor says, okay, this is a good results and we want to public this, then this is possible to make an publication.
Yeah.
No.
For Reinval, it's maybe on bachelor's, but still could be relevant because you also have master's programs. And is it possible to be academically also active in terms of publishing?
So we're a Fachhochschule, so we're a little bit bitty in which of the staff do research, and because we're between engineering and science, we have arguments all the time of what really counts as research. So it's a little bit difficult to answer the question. We have, for example, actually the three of us who originally come from England all have research projects, and particularly the master's students do much of the work. We don't have very many PhD students, so the master's students have to do the work on that. And at the end of both the master's and the bachelor, there's a project, a thesis, and that is usually some kind of research. If we are lucky, so they end in a paper.
All right, thank you. Let me stay with you and then voice this question for both, but since for bachelors, it's always difficult to really know what you want to study and people keep changing the topics. One of the questions is the thing that I'm not sure whether I will be able to tackle the course. Do you offer any aptitude tests just to find out whether the course fits the applicants?
For me,
Yeah.
we are going to. We haven't started it yet. We're writing them currently. So unfortunately, we don't have them. But that is our current job, is making them for the future. So we're going to make a thing which we call online self-assessment, OSA. And to help with that, we do publish the entire contents. So the module handbook is entirely open and free to download, and anybody can download any of them. It is obviously rather written in teaching language, so it's not particularly accessible, but you do see what the content is and what to expect. The easiest way to check better is to contact some students and talk with them, because they know more how hard it is. Because it's hard for me to. I don't really appreciate how difficult it is to take the course, because I never do it myself. What I did want to say at that junction, though, is traditionally we have a good relationship with this other course called Bioengineering. So our students, if they find it difficult, tend to switch between the two. And we facilitate that reasonably. We allow them to take a lot of courses with them. There is a difficulty, however, because most natural science courses contain mathematics, and that's usually what students find difficult. So it does cut it down a little bit. But we do have a relatively active interaction with this bioengineering course, with students coming to us from them and going to them from us. And it's not too difficult to do. Changing inside a university in Germany isn't too difficult, and you can take a lot of credit points with you. Now, going to a different university is not so easy.
Yes, exactly. I can confirm that. Thank you very much. And Dr. Renke, could you also voice this question, like, or your
So
feedback?
we have we have in Freiberg no tests for master thesis. As if for master courses, for bachelor courses we have preparation courses, but it's only in German. And not relevant if you want to start in if a student want to start in a master course. Actually no, but perhaps I hope it in the future.
Yeah. But for masters, it should be more or less easier because you already did similar bachelor, so you probably know your abilities and then your interests, and then could then correctly locate yourself. All right. There was one more question. I think it came during the Rheinwald presentation, but I also don't think it was the same course Anastasia was addressing. So the question is, there are a lot of mathematics and programming in this curriculum. So do you expect us to have basics in programming? If so, which language?
No is the answer for us. So we have I can't see where it is, but because I've got too many bits of paper, but we have a programming course. We have mathematics and we have a programming course. And our programming course is it was in MathCAD. It's now in something else, Python, I think. But they start from basics. It's really about how to program in a simple language, and they just use the language as a way to teach it. You have to do a language. The goal is to be moderately capable at programming and not particularly anything else. Although some of them get very good. So depending on whether they're interested or not. So we don't expect them to have programming basics beforehand. The mathematics is always a little bit of a cultural difference. German mathematicians and everybody else's mathematicians work slightly differently. So there is an interface there, which usually takes a bit of time, but then it's all right.
Thank you. And the question about specialization for Dr. Renke, it was about metallurgy, but is it possible to specialize in anything else? Is it possible during the electives?
Yes, because we have 5 institutes, important institutes. It's also possible to elect the other institute if the student want to write the student work or the master thesis at the other institute. But in this case, the student can say, okay, I go in the pure material scientific, also in the material science and development of materials. He can also say, okay, I go to in the field more in the analysis of materials. Yeah. It's possible, but it's not. It's not a part of the study regulation. It's a decision of the student. Now he can say, okay, I make my research project and my master's thesis, for instance, at the Institute of Experimental Physics, or only at the Institute of Electronic and Sensor Materials. Now, also, if the student want to do it, then it's possible.
All right, thank you.